Today we are going to begin our unit learning about projectiles. A projectile, as you can see, is anything launched, thrown, shot, hurled, tossed, kicked, or in any other way sent flying through the lack of air. You'll notice it says lack of air because what we're going to do for our equations anyway is we're going to assume there's no air resistance. We will talk about what air resistance does to a projectile, but as far as calculations are concerned, we will ignore it. There are other terms besides projectile that you need to know. The first one is trajectory. As you can see, the trajectory is the path of the projectile. Whatever shape that path is depends on how the projectile is launched. The second term is range. The projectile range is the horizontal distance that the projectile travels. If you are going to be doing anything from shooting a free throw to shooting a rabbit to shooting a cannonball, you need to know the range because you want to make it land on the right spot. Then there is hang time. That is the projectile's time of flight. Hang time can be important, for example, in football. If you are kicking a punt, you might want to have a long hang time because it gives your teammates time to get down to the other end of the field where the ball is landing so that they can tackle the person who's catching the ball. We are going to focus today on vertically launched projectiles. They are the simplest kind of projectile, and I think we should start with something simple. When a projectile is launched vertically, it's experiencing only acceleration in what direction? To answer this question, we have to think about what's the only thing acting on the projectile when it's flying through the air. Oops, wait, no air. When it's flying through the lack of air. Right, if you think about that, the only thing that's acting on it is gravity, so therefore it's going to be accelerating downward because of gravity. What happens to the projectile at the top of its flight? You know the answer to this question already, and then several of the questions that are going to follow because you did the video with the vertically launched projectile. So you should already know the answer to this question. What happens to the projectile at the top of its flight? Of course, is going to come to rest. It's going to travel up, it's going to stop, and then it's going to travel back down. Because it comes to rest at the top of its flight, we are going to say the final velocity of the projectile at the top is 0. Notice here this is not written properly. The format of my PowerPoint was messed up. This should be V with a subscript F top equals 0. So apparently subscripting is not something this particular program can handle. What happens to the acceleration of the object at the top of its flight? Well, we know that its velocity goes to 0, so does that mean its acceleration also goes to 0? Well, we know that can't be the case because if its acceleration went to 0 at the top of its flight, there would be no reason for the object to come back down. It must still be undergoing the acceleration due to gravity, and that is why it falls back downward. Notice the acceleration due to gravity is 9.81 meters per second squared. Once again, the formatting is messed up on my PowerPoint. As this slide said, we have to make sure that we make gravity negative when we're expressing it because the velocity was upward and gravity is downward. The way we show that they are opposite directions is we make one of them positive and one of them negative. Up is always positive, so therefore gravity must be negative. How does the time of flight up compare to the time of flight down? Well, as you saw in the video, the two times are pretty much equal. The only thing acting on it is gravity. It's the same value of gravity in both directions, therefore the time of flight is the same. What we're going to do now is we're going to do an example problem of how we would use math with vertically launched projectiles. So here's the example you need to write down. Johnny throws a baseball straight up with an initial velocity of 25 meters per second. The first question we're going to answer is what is the time of the flight of the ball if it returns to the same height from which it started? We're always going to have to assume it returns to the same height from which it started in order to make some of these things we just talked about be true. So let's go with that. So assuming you have this question written down, let's work out how we solve this problem. The first thing we have to do, of course, is the givens. When we're doing the givens, we want to start with what we know are the understood givens, the things we just talked about. For instance, we know that at the top of its flight, the velocity of the ball is 0, so we can put a given of V final at the top is 0. Well, what else do we know? We also know the initial velocity of the ball, since that was given to us in the problem. We know the initial velocity is 25 meters per second. In addition to this, we also know that the object is undergoing the acceleration due to gravity, so we know its acceleration is negative 9.81 meters per second squared. And we are, of course, looking for t. Looking at these givens, we know there is only one kinematics equation that's going to be able to solve for t for us, and that would be our v final equals v initial plus at equation, or actually you could also pick a equals v final minus v initial over t. I'm going to go with the first one. Notice I have used v final top here because that's one of my givens. If I'm looking for v final top, that would mean I am actually finding t at the top, so I need to fix that in my equation. Now all I have to do is substitute in what I know and solve for t. So when I substitute that in, I have 0 meters per second equals 25 meters per second plus a negative 9.81 meters per second squared times t top. So I subtract the 25 meters per second from both sides, so I get negative 25 meters per second equals negative 9.81 meters per second squared times t top. Now to solve for t top, I divide both sides by negative 9.81 meters per second squared. When I do that, the 9.81s cancel out on that side, so I'm left with t top is equal to 2.55 seconds. So that's our final answer, right? Of course not. It did not ask us what is the time for the ball to get to the top of its flight. It asked us for what is the time of flight of the ball. We've just figured out how long it took it to get to the top. So to figure out how long it takes it to get all the way back to the bottom, we need to use the fact that time up equals time down, and from that we can find the total time simply by doubling the time to the top. So the total time, t total, is equal to twice that, so that would be 5.10 seconds. As I said, we got that by doubling the time to the top, and that's what you'll do in these kinds of questions. Next, we want to figure out how high the ball goes. To get the vertical height of the ball, we are going to have to solve for d in the vertical direction, of course. So we need to think again about what do we know. Well, we have the same givens we had before. VI is 25 meters per second. Acceleration is negative 9.81 meters per second squared. We want to know how far it goes to the top of its flight because we want to know how high it is. So we will use t to the top to figure out the distance, and t to the top was 2.55 seconds. So all I have to do now to get the distance is plug that information into the distance equation that we know and love, d equals vit plus 1/2 at squared, where the a in this case is the acceleration due to gravity, g. So we'll plug in those numbers and we'll solve for d. Had to move that to make it fit. And then we just simply solve. Please don't forget that gravity must be negative 9.81 meters per second squared, and that the time in the second term here is wow, that was cool. The time here, okay, sorry about that little earthquake there. The time here in the last term is, okay, I don't know what I'm doing. There we go, squared. Don't forget to square that time. All right, so simply plug it in your calculator and solve, and you should come up with the answer. I got 31.86 meters. I hope you worked it out too to see if you get the same answer. Notice the units are meters because in the first term the seconds cancels out the seconds in meters per second, leaving meters. In the second term, the second squared cancels out the second squared to the bottom of meters per second squared. So the last question is, how fast is the ball going when it finally reaches its original height again? So this time we are looking for V final, but not V final at the top. We're looking for V final at the end. We know V initial was 25, still the same given that we had before. We know the acceleration is still negative 9.81 meters per second squared. And we know the time. Now this time we want the time at the end, so therefore we want the total time is 5.1 seconds. So all we have to do is go back to the equation that we used before. V final equals V initial plus AT, or GT, and solve for V final. V initial was 25. A is negative 9.81 meters per second squared, and T is 5.1 seconds. When you do that math, you get V final equal to negative 25 meters per second. This should hopefully make sense to you. The ball had an initial velocity of 25 meters per second upward. The only thing acting on it the whole time, the thing that slowed it down and brought it to rest and then brought it back down, was gravity. Gravity didn't change, so it makes sense at the bottom it has the same speed it had at the top, but going in the opposite direction. Hence the negative 25 meters per second. These are really the only things that they are going to ask you to solve for when you are doing vertical projectile problems. The time of flight, the height at the top of the arc, or the top of the flight, and the speed at the bottom. You could be asked the height at any particular time in its flight. In that case, you would just solve for D using the time they give you. Okay, hope this all makes sense. If it doesn't, replay it, and if it still doesn't, write down your question so that you can ask me in class tomorrow.